Hello, welcome back to the channel. Let's tackle another challenge. Today's problem is problem number 314, binary tree vertical order traversal. So let's see what we are given. So we are given the root of a binary tree and we need to return the vertical order and traversal of its node values, i.e. from top to bottom, column by column. If two nodes are in the same row or the column, the order should be from left to right. So let's see. So we have this example. We have a couple of examples here. Before we look at examples, let's see the constraints. The constraints are saying the number of nodes in the tree is in the range from 0 to 100. And node values are from -100 to 100. Okay, let's look back to the problem again. So we are given this tree root, right? And this is a root of the tree, and it has a left child, it has a right child, and the root is, if we put this column levels in the horizontal and the row levels and the vertical, so the root is located at this column 0, and we can increment the column 1 and the column 2, and if the root has two child, 9 and 20, and the left child is going to go to the column -1, and the right child is going to be column 1. And if any of the child of the root, for example, the 20 has a left child is going to go to the left, which is going to be in the same column as the root, which is, this is a column 0. This is also a column 0. This is a column -1. This is a column +1. This is a column +2. So what we need to do, we need to collect this. We need to collect the rows, or I mean the nodes in the same column, from left to right. Let's say from 9 in the first, we have only 9, and column 0, we have 3 and 15, right? And column 1, we have only 20, and column 2, we have only 7. So let's look at another example. So we have a column in the horizontal and vertical in the row. Let's say this is again root, and we have a left child, and we have a right child. And if this root is going to be column 0, and the left child is going to be column -1, and -1, it has two children, and the right child going to be column 0, and at the same time left child of the right child of the root is going to be column 0. And this one is going to be -2 column. This is again -1, and this is 0. And if we collect all of them, first root is coming, right? And from left to right, the 10, 9, and finally 6. And here we have only 3 in column 1, and column 2 we have only 11. Right? And if we just collect this, so all we need to do, we will need to return the list of these nodes. For example, 9 and 3, 15 and 20 and 7. We need to return the list of these lists. So what we're gonna do here? How we gonna solve this? So we would solve this with we have already solved a few more problems in the BFS level order traversal. I think this will be a very good candidate for that. So we do BFS, breadth first search, level order traversal, traversal. So what we get the queue initially, and in the queue we add the node and column label, right? Which column it fits in. Let's say initially we add to this queue, and then what we're gonna add the first the root, right? We need to start from the root. So how we gonna look at which node belongs to which column, right? So what we do, we keep one table which is column dictionary. That's where we're gonna collect column and corresponding nodes, we collect them in the list. Let's say in the first column, in the column 0, right? Column 0, we collect, for example, in this example, right? We collect as a list 3 and 15. And the column 1, we collect 20. Column -1, we collect 9. And column +2, we collect 7, right? After we collect all of these, what we will do, we are going to at the very end, then we need to construct this list, right? List of lists from this dictionary, right? From this dictionary. How are we going to do this? So we can do initially, while we are doing this level order traversal, what we do, after we pop from the queue each node, I will show you in the code how we're going to do that. We need to at the very end, we need to return this this list. How are we going to do this? We will iterate from each node, right? We'll iterate from what's the minimum column. Minimum column is -1 and maximum column is 2. So what we need to do, we need to keep the variable while we do this level order traversal. We are going to keep this variable minimum column and maximum column, right? Because we need this, when this two numbers, minimum column and maximum column. What's the leftmost? Let's say, what's the leftmost here? What's the minimum column? What's the maximum column, right? Max column. So minimum column in this case is -1, right? And the maximum column is going to be 2. So all we need to do, we need to get in the very end, we need to return the dictionary, we need to return the list, right? What we'll do, column dictionary, let's say column dic. We need to get each value of the inside the list, inside this dictionary. We need to return this one, right? We need to return this. We need to collect all of these guys, right? Starting from the minimum column. What we do, this is a list comprehension. So for x, this is a for x in range from what? From minimum column, right? Up to maximum column, right? In Python, we need to add 1 because it started from 0, right? At the very end, we are going to return this. So basically, this will do our work. So let's see if we can quickly code. Okay, yeah, we are given the root of the node. So what we need to see if the if root is not given, if the root is none, so we need to return empty list, right? Oh, we need to return empty list. Then we need to declare this dictionary. So dictionary is the list, the column dictionary, where it collects the column and which nodes belong to the specific column. Then we initialize the queue, we add the root to the queue, and that root will be in the column 0. Then we initialize max min column and max column to be to 0. Then what we do, we say while queue is not empty, we get the level size. Level size is basically the length of the queue, right? Then after this, we need to go to for. We need to iterate this through the queue for in range. We need to get the level size, right? We need to get the level size. Then we need to pop the node from a queue and the column index, right? Column index from the queue, which is queue dot pop left. Then we need to check if this node is not empty, right? If node is not none, then we need to collect this into the dictionary. Then we need to collect this, we need to add the left and right nodes, right? So if the node is not none, then we need to add this node value to the column index. And initially minimum column we initialize to 0, maximum column initialize to 0. Now we are updating minimum column to be the minimum of the minimum column and the column index, right? And the column index, as we go down from the list, from a level, right? From the first level, and from the first level, second level, right? This is like we need to update the column to be, let's say, -1 and +1, right? So we need to get, initially it was 0. Now to get the minimum column, we need to get the minimum of -1 and 0. So we need to update this column to be the -1, right? So for that purpose, we need to update this to be minimum column and a maximum column. It's going to be the same thing. So at the very end, we are going to use this, right? If the left child of the node exists, then we need to add that node, that left node to the queue. And at the same time, that node will be the existing column index -1, because it needs to go to the left or it needs to go to the right. If it's a right node, it goes +1. If it's left node, it goes to the current column index -1, right? Then here we're gonna, after we exit this while loop, after we are done executing all of the nodes in the tree, then we initialize the output. Then we go to from minimum range, minimum column to maximum column +1. We get, for each column, we iterate to be the column then we add here within this in the column dictionary, we collect all the nodes within the list. So we add this list back to the output, right? We basically put all of the list from left, from the minimum column to the maximum column 1 back to the list, right? Then at the end we return the output. So after we are done, then the time complexity of this algorithm is going to be O of n here being the number of nodes, and space complexity, this is time, and space complexity, it's going to be O of n, because we're collecting them within the dictionary. Yes, I think that's it. I think this will do, and this code will run, and it runs with O of n time. And if you like this explanation and this walkthrough of this problem, yeah, please subscribe to the channel and ask your questions and what kind of problems you would like me to make a video or explain. Okay, thank you guys. See you in the next video.